Hi everyone. Today we are going to discuss expansion of a function by method of using Leibniz theorem. When we think about the expansion of function may be trigonometric function may be exponential function. We have to expand it by Taylor's and Maclaurin series also. And also there is another method for finding the expansion of given function, that is Leibniz method, or that is a Leibniz theorem. Means by using the Leibniz theorem we have to expand the given function. You have to first learn about what is the Leibniz theorem. So when we think about this expansion of function and by using method of Leibniz theorem, so first of all you have to study here what about Leibniz theorem. Leibniz theorem. So basically you have to statement of this Leibniz theorem, it is depend on and successive differentiation of product of two function, guys. Successive differentiation of product of two function. So what is the Leibniz theorem says? So Leibniz theorem says that, what is the statement I am writing here? Statement of this Leibniz theorem, it says that if u and v are the functions of x, means I am writing here, if u and v are the functions of x whose nth derivative are known, whose nth derivative are known, means there is a condition is there, there is a condition is there, means whose nth derivative are known. What is the condition? If u and v are the functions of x and whose nth derivative are known, then and then you have to write the successive differentiation. Means here y is a function of here u and v, y is a function of here u and v. So let me write now this in this way, y is equal to u and v. That is, if then if y is equal to suppose u and v, so then it's a yn, and yn is nothing but it is a nth derivative of product of u and v. So how to take the nth derivative of this? So this is very easy to understanding. Suppose you have to write the first nth derivative of un at that time v as it is. Next plus second term is what is that here, nc1, means I am writing the properly in this way, guys. This is nc0, that is Leibniz theorem says that this is nc0 un into v plus nc1 here un minus 1 the derivative into here the derivative of again v is a v1 plus nc2 un minus 2 into v2 plus and so on. You will have to getting plus ncn here un minus n, that is a v is a, means u term is as it is and the derivative of v as n times, that is a vn. So this is simply Leibniz theorem for product of two function. Now this theorem can be proved by using also mathematical induction, guys. So what is the statement you have to observe here? What is statement you have to observe? So what is this nc0 ncr? So there is a formula, so where ncr, that formula becomes, that is n factorial divided by r into n minus r factorial. Look at this formula. Now this is very easy to understanding. Look at this formula ncr, and if we substitute here r as 0 1 2 3 4 and so on n, you will have to getting here the terms as nc0, where r is equal to here 0, we have to substitute 1 2 and 3 and so on etc. You have to put the values up to n, and always remember that here r is less than or equal to n, guys, and r is less than or equal to n. That is condition for using Leibniz theorem. So by using this Leibniz theorem, so I want to discuss in this session, by using this Leibniz theorem we have to expand the given function. Means with the help of this Leibniz theorem we have to expand the given function, and that method is called as expansion by using method of Leibniz theorem. Now let me start some problems or some discussion about the how to expand the given function by Leibniz theorem. Suppose I have to expand e to the power x by using Leibniz theorem. So let me start. So for example here, suppose I want to do expand simple function is there. Suppose e to the power x, we have to expand. So how to expand it, guys? How to expand it? That is your for example. So let's see, this is easy to understanding here. So how to expand this? So let me start. What is the solution is there? Let's see. You know very well by Maclaurin series. In Maclaurin series, the statement is also in terms of what is that y of 0. Let you know that. So I am directly writing here let by using Maclaurin series, guys, by using Maclaurin's series. So I wanted to just write here by using Maclaurin series means we have to expand e to the power x and again extend the question as and suppose prove that here what is the statement of this. I would like to here also extend the question as now in this way, expand e to the power x and here prove that e to the power x, it is nothing but it is a 1 plus here simply tan x plus tan square x upon simply here 2 factorial minus here tan cube x upon here 3 factorial minus 7 tan raised to 4x upon here 4 factorial. In this way we have to expand, guys, by using which theorem? That is a Leibniz theorem. So let me start how to write its solution, means how to write its proof, guys, how to write its proof. So let's see, by Maclaurin series, you know that I am writing here by Maclaurin's series. What is a Maclaurin series expansion formula? You know very well. Suppose y is equal to f of x, then y is what is that? Y of 0 plus here theta into theta means here you know the I am taking here substitution for theta here y1 of 0 means suppose h into y1 of 0 in this way. Now next one is what is that here theta square upon 2 factorial into here y2 of 0 plus and so on now in this way, plus and so on now in this way. So also again you have to taking for that y is nothing but here is a given function, guys, y is nothing but here given function, and let me here let I'm substitute for tan x that is equal to theta, tan x that is equal to here simply theta. If tan x is equal to theta, then that implies that what is value for x? Value of x is simply here tan inverse of theta is there, tan inverse of theta. So again I am taking logarithm on both sides, or we have to taking exponential power of this given function, means it is a e to the power here simply here tan inverse of theta is there. So therefore e to the power x, that is a function of x, and let for that also I am taking let that y is equal to here. So clearly y is a function of x, that's why I am taking y is e to the power x, and e to the power x is nothing but here is a tan inverse of here simply theta, guys, tan inverse of theta. So therefore differentiating the equation with respect to theta, suppose for consideration we called that first equation and we called that is a second equation, right? Now we have to differentiate that equation 2 with respect to theta. Suppose I wanted to differentiate here. Now simply because you have to differentiate or you have to expand this term by using which? Leibniz theorem. So I am writing again in a question by using Leibniz theorem. By using Leibniz theorem. Using the Leibniz theorem, we have to just differentiate, guys. We have to just differentiate. So differentiate equation. What equation? Equation 2 with respect to, guys, here theta. With respect to here theta, because theta is an independent variable. That's why we have to differentiate with respect to theta. Therefore differentiation of y with respect to theta is taken as a y1. That is the first differentiation is there, and here is e to the power x derivative means it is e to the power tan inverse theta as it is into tan inverse theta derivative is 1 upon 1 plus theta square. That is a differentiation we called for reference. This is equation number 3. Again differentiating equation 3 with respect to simply here theta. So again, if you have to differentiate this, so what you will get here, this is a 1 plus, clearly what you will get here, 1 plus theta, this whole bracket square, this theta shifted on here into, again differentiation of y is a y2, that is equal to, means I am writing here the plus, because of that that e to the power x theta, means the above term can be written as, guys, above term can be written as now in this way. So let's see. So this can be written as, this is a 1 plus theta bracket square into y1, that is equal to e to the power again tan inverse of theta as it is. Tan inverse of theta is remaining is there, and that is nothing but it is what, y. That is nothing but it is, what is that, y. So differentiate that equation I am considering here 3 with respect to theta. So clearly what will get here, 1 plus theta, clearly what will get here, 1 plus theta square into y2, because 1 plus theta square as it is, and taking derivative of y1 as a y2 is here, y1 as a y2, plus here 2 theta y1 is equal to y derivative is y1. So this is differentiation I am taking here. So we called for reference, that is equation number 4. Equation number 4. Now let me explain in next page. So therefore what we will have to get in here, that is 1 plus theta square into y2 plus here 2 theta into y1, that is equal to here y1 we called, that is equation number 4. So again differentiating, now I am writing here differentiating equation 4, guys, equation 4 with respect to theta n times. But how to take its a differentiation with respect to theta n times? So using Leibniz theorem. So I am writing here, clearly mentioned here, using Leibniz theorem. Using Leibniz theorem, guys. I hope you have to understand this, how to using the Leibniz theorem. So you know, guys, very well what is a statement of Leibniz theorem. If u and v both are the two functions, then it can be expanded into nc0 u n v plus nc1 un minus 1 v1 plus nc2 un minus 2 v2, and in this way ncn u vn. So that is Leibniz theorem. So we have to use here Leibniz theorem, guys. It is differentiating n times. So therefore what will I have to get in here? If you have to differentiate by Leibniz theorem, means it's nth order derivative I wanted to write is here. So 1 plus theta square, this term considering as v and this term considering as u. So that's why you have to observe here. Means here un nc0 un v as it is. Means 1 plus theta square as it is, and un, its a derivative is nothing but what is that here, yn plus 2, because already y2 is there. So nth derivative is yn plus 2. Again I wanted to write here the next term is what is that, so let's see, I am writing once again here what is the statement of Leibniz theorem. So let's see, let Leibniz theorem says that if your function is yn, means you have to taking nth order derivative of y is nothing but that is u into v, y is nothing but that is u into v. So let's see uv and its nth derivative we have to take in here. So how to take here? So nc0 un v plus nc2 un minus 1 into v1 plus nc, here 1 is there, nc2 un minus 2 into v2 plus and so on, plus ncn u as it is here, and here is only what is that, vn is there. So here you have to observe what is u and what is v, guys. Here you have to observe what is v and what is u. U is, its nth derivative is known, therefore u is y2 and v is 1 plus theta square. So let's see, I am mentioning here u and v. So using this theorem you have to expand it. So let's see. So this will becomes 1 plus theta square means v as it is into y2, its nth order derivative is yn plus 2 means here nc0 u into v plus nc1, what I am writing here, plus nc1 yn minus 1 means it's a derivative, it light becomes, that is a yn plus 1 means it is only 1 plus n theta square, its a derivative is 2 theta guys. So I am writing for that. So this is 2 theta, this is 2 theta into n, that is yn plus 1 because n minus 1 the derivative is there, plus next term is what is that here, nc2, here again derivative of this theta, 2 theta, 2 theta, it becomes here 2 into here n as it is into yn is there only, yn is there only. So therefore this can be written as plus and so on. So I am writing this next derivative is again, that is it remaining only 2 theta yn plus 1. Next one is what is that here, 2n means n into 2 yn, and that is equal to RHS y1 is there, so its nth order derivative becomes yn plus 1. So therefore clearly what we'll have to getting here, this is a 1 plus theta bracket square, nc0 means here 1 into yn plus 2 plus nc1, you know the what is that, how to write this, this is a 2, nc1 value is n, so I am writing here that is a 2n theta yn plus 1 plus next term is what is that here, n into n minus 1 into yn is there because 2 and 2 get here cancel, plus next term is a 2 theta yn plus 1 plus 2 theta yn plus 1 plus 2n yn, that is equal to yn plus 1. After again simplifying, it will get 1 plus theta square, at that time derivative of y is yn plus 2 plus 2 in bracket, I wanted to write the common terms is here n plus 1. So which are the common term, 2 theta yn plus 1 means I am writing now here, that is a 2 theta yn plus 1 and n plus 1 is means these are the common terms, we have to adjust for that 2 terms. So here you have to observe and here you have to observe, so I am taking here common term. Next minus here yn plus 1 because RHS term I wanted to shift it in LHS, and plus here n square plus n into yn, and that is equal to here guys clearly 0. So now putting x equal to 0, why we take the x is equal to 0 in this putting, because of that so where is this equation, so putting x is equal to 0 in which equation, in equation 2, 3 and 4, 5. So therefore what will becomes the values of y0, it is nothing but here is a 1 means x is 0 in equation 2. So let's see what is equation 2 guys. Equation 2 is y equal to e to the power tan inverse theta. If we substitute this is 0, so y is equal to 1. Also from equation 3, what is that here, y1 of 0 means put x is equal to 0. So what will get here, also 1. Also y2 of 0, it will get also 1, and so that implies yn plus 2 of here clearly 0, yn plus 2 of 0. So what is that here, this will becomes yn plus 1 of 0 minus here means using this Leibniz theorem minus here n square plus n into yn of 0. So therefore putting for values of n is equal to 1, 2, 3, 4 and so on in equation. So I am writing this equation number as 6. Because of that, you know that equation I am mentioning here 5 and that equation is 6. So putting n is equal to 1, 2, 3, 4 in equation 6. So what is equation 6? Again I am writing here. So equation 6 as let equation 6 as that is yn plus 2 of 0 is equal to, that is a yn plus 1 of 0 minus n square plus n, that common term is there, into yn of 0. So here what you have to putting n is equal to 1, 2, 3, 4, etc. and so on in above equation. So guys, for consideration, this is equation number 6. So if we are to substituting this n is equal to 1, so what we'll have to getting here 1 plus 2, that is we have to getting here clearly y3. So y3 of 0 means I have to write here very clearly. So y3 of 0, y3 of 0 is equal to n is equal to here 1 means y2 of 0 minus n is equal to here 1 square, 1 plus 1, that is minus 2 into y1 of 0. So clearly it will have to getting that here 2 into y1 of 0, 2 into y1 of 0. So therefore this is equal to, what is the y2 of 0? You had already find the y2 of 0, that is equal to 1, and minus 2 y1 of 0, y2 of 0 that is equal to 1 minus 2 into y1 of 0, that will get again 1. So 1 minus 2 into 1, that is equal to minus 1. I hope so you have to understand this very well. Also if we put n is equal to 2, we get here y4 of 0, and y4 of 0 it will get y. Now this is a 4 means 2 plus 1, that is a 3 of 0 minus 2 into here. What is the value of 1? N is here 2. 2 square, 4 plus 1, that is a 5. 4 plus 1, that is a 5, means 4 plus 2, that is a 6, means I am writing here, that is 6 into y1 of 0. So this term as a 6, guys. This term as a 6 into y1 of 0. 6 into y1 of 0. So you know the values for y3 of 0, you have to calculate now. Recently y3 of 0 value is uses here minus 6 into y1 of 0. y1 of 0 you know very well. What is the y1 of 0? Let's see. That value is equal to, what is that? 1. That value is equal to, what is that? 1. So therefore this is equal to minus 1 and minus 6, it will get minus 7, and so on and so on. Means we have to again substitute here, what is that? N is equal to again 1, 2, after we have to substitute here 3 also, after we have to substitute here 4, and so on. So therefore equation 1 as so what is that equation 1? This is y is equal to, by Maclaurin series we have to already discuss here. Equation 1 as, what is that? Y of 0 plus theta into y1 of 0 plus theta square upon 2 factorial into y2 of 0 plus and so on. That is a Maclaurin's series. Now putting all these values in equation number 4. So I am writing here putting values of y1, right, y1, y2 and so on in equation 1. So therefore 1 means above equation. So therefore y is nothing but, we have to already discuss, y is e to the power tan inverse of theta. We already said y is tan inverse of theta, and that is equal to y1 of 0 means y of 0 value becomes here 1 plus theta into y1 of 0 is again 1 plus theta square divided by 2 factorial, means it is nothing but here y2 of 0, you know the value of y2 of 0, that will get here minus 1. So it will be 1 is there. Next y3 of 0 means minus theta square divided by 2 factorial plus y3 of 0, that will get minus 1. Now next, suppose I wanted to put the value of next value theta raised to 4 upon 4 factorial into y4 of 0, it will get minus 7. So therefore that implies it is e to the power tan inverse of theta, that is equal to here 1 plus theta square divided by here 2 factorial. Now this minus theta cube divided by here 3 factorial minus here 7. So this is 7 theta raised to 4 upon 4 factorial, theta raised to 4 upon 4 factorial. So that implies e to the power tan inverse x. Resubstitute. What is the resubstitution here? Here x is equal to, what is that? Tan inverse of theta, and theta equal to what is that here, tan x. So we have to resubstitute, and therefore what will you have to getting after this step? This is e to the power tan inverse of theta means what is that, x, and that is equal to 1 plus theta means, you know very well, theta means here tan x. So here expansion, that is a tan x, plus theta square means here tan square x divided by here 2 factorial, minus here tan cube x upon 3 factorial, minus 7 tan raised to 4 x upon 4 factorial. In this way you have to getting the expansion series of e to the power x by using which theorem? By using Maclaurin's theorem, guys, by using Maclaurin's theorem. I hope you have to understand this very well, what is the concept of Leibniz theorem. So this is done by using Leibniz theorem, guys. Means we have to expand this function by using Leibniz theorem. So process you have to see again. We have to take the first as expansion by using Maclaurin series, then you have to consider the value for theta as x, and you know the it converted into y, and so y is e to the power tan theta, and then you have to calculate what is y of 0, y1 of 0, and by using the Leibniz theorem, so we have to take its nth times differentiation, and after that we have to substituting only the given above equation number 1, so which is equation 1. So let's see, this is equation number 1, and in this equation we have to substitute the value of y of 0, y1 of 0, and you will have to getting this answer. I hope you have to understand this very well. Thank you.